Okay, it appears that we have a bad capacitor in my pool pump. Thought I'd show you how to replace the capacitor. First off, the reason why I think it's a bad capacitor is because when the pump tried to turn on, it'd make a large electrical humming sound. And what I did is I went ahead and pulled the top off of this impeller, and I made sure the power was off, and I spun it by hand, and it spun freely. So there's not a whole lot else that could be wrong. It could be that the motor is burned out, or it could be the capacitor. I think in a lot of cases it's the capacitor. And the capacitors that fail in these things apparently are generally the run capacitor. You can see this large hump up on top of the motor here. That hump, underneath that hump is the capacitor. Now before I go doing anything with this unit, I want to disconnect the electrical power, because as you know, they can turn on automatically, and that wouldn't be good if I'm working on the electrical system when it tries to turn on. So I'm going to head over and back to the panel that runs the pool where the clock is. Open it up. It's in the off position, but I want to take it one step further. Be sure that the breakers are off. And these are the breakers that run the pump. So I've got it off, got the breakers off. Should be a little bit more safe to work on now. Got all my tools laid out here, probably everything I'm going to need. And so it's pretty simple. Just pull these couple of screws. See if that's right. Okay, we've got our capacitor sitting under there. It's sitting on a little foam block. I think the reason why they do it this way, you can see that there's like a little ridge right here, and it prevents the capacitor from going so far forward that it could short out on the metal in here. Also, that foam block absorbs some of the vibration and makes it so the capacitor should last, shouldn't be vibrated too hard. Before you touch one of these, the capacitor, even though the power is off, can charge up an electrical charge. It can store a charge. So you want to kind of be careful that there's no charge inside this capacitor. I'm going to cover it up because I've heard that there is a possibility of an explosion with a big capacitor like this. And I'm going to make sure that the capacitor is discharged by touching some metal across these two terminals. Now, since the power is off, it doesn't much matter that I touch these terminals, but if there's a little bit of a charge inside this capacitor, it'll release that charge, so there's no chance of me getting shocked and no charge of it exploding. So I'm just going to touch it like this. That's all it takes. Touch these two terminals. Makes the capacitor safe. Next thing, I'm going to go ahead and pull off the wires. Okay, got that done. And the reason why I covered it is just on the remote chance that there was a problem with it. I wouldn't get hurt. Kind of a safety thing. Okay, on this particular capacitor, you can look at the rating, and it says on it that it is a 25 microfarad, if you can see that right there. It's rated for 370 volts. And it's a 50 or a 60 hertz unit. 25 microfarad, that's written as 25 UF. That's a pretty powerful capacitor. I went out, found one that would fit under the cover, a new one. And the new one is actually rated 30 microfarads. It doesn't matter if you up the capacity a little bit. You wouldn't want to go down with the capacity. The rest of the specifications are all the same. Now, something that I think is kind of important to do is you can actually test a capacitor with a multimeter, and it's kind of difficult to do holding the camera and all. But I've got a multimeter here. Try to bring this around so you can see it. I've got the multimeter set on the lowest setting for ohms. When I cross the terminals like this, the multimeter comes up to 0 ohms. So I know the multimeter is working. Now, what I can do is I can test one of these capacitors. First, I make sure it's shorted out so that there's no charge in it. Just double check that. Then I'm going to touch both sides. You can see that the meter did not jump up at all. Now on this, I'm going to do the same test. You touch both these terminals, make sure the capacitor is not charged. Now I'm going to touch both of them and watch the meter. Did you see how the meter jumped up and then it went back down? That's exactly how a capacitor is supposed to work. When electricity goes into a capacitor, initially the resistance is very, very low, and then it gets higher and higher and higher until the meter drops back down to 0. So doing that tells me that this is a bad capacitor, and I'm going to get out of my way so I don't try to install it. This is my brand new good capacitor. I'm going to take this capacitor, lay it down in here. I'll go ahead and hook up the wires. Push that on real good. Push this on real good. Okay, so that's nice and secure. And I got to find my cover now. And you can see that I've got this ridge on the cover, where it should kind of prevent the capacitor from coming too far forward in the cover, because I don't want to touch any metal and short anything out. So put that cover on there nice and careful. Line up the holes. See if I can start this by hand, which looks like I can. And there's my other screw. I'll line up that hole. Okay, not too tight, or you can strip them out. Just kind of firm. Okay, that's down. Well, I believe that it's time to go flip on the power and see if this thing's going to work. Head back to the clock. You turn on the circuit breaker. Turn on the pump, the timer. And the pump is now working. You should realize that occasionally when a pump motor capacitor fails, sometimes the motor will start and sometimes it won't. A capacitor does nothing more than just give a motor a little bit of a kick when the motor needs it. So there's going to be times, it won't blow your fuse every time when you have a bad capacitor, but it will start acting up, giving you trouble. And especially when things heat up, you'll find that if you've got a bad capacitor, the motor may just sit there and hum. And don't let the motor hum for very long, because it'll start burning out the windings in the motor, or it'll blow a fuse or something like that. So that's what this motor was doing, and that's what made me come out and change the capacitor. And we successfully tested the old one and verified that it is defective, and we've got the new one installed. I hope that this can help you out.